Good morning, everyone. My name is Cheng-Hao Wang, and today I'm going to talk about the patterns of fluorescence associated with citrus peel defect. So I will going to divide into 5 parts. So first is my introduction. So what is the fluorescence? It is when the electrons absorb exciting light, it will be excited to the high energy state, and it is unstable. So when it transfers back to the ground state, it will release the energy as a form of light, and that is the fluorescence. So this experiment is a combination of machine vision and image processing. And the reason we want to use the fluorescence is because the citrus will fluoresce on the defective area because of the peel oil will spread from the defective area. And it will, even though some fruits looks very normal, so we want to identify the possible reason of the fluorescence. And then is the material and method. So we first use the machine to sort out the defective fruits. And this equipment is a developed machine in Kawakami grading facility. And it is based on the fluorescence image. So it includes a moving conveyor with UV and LED. And each fruit will get fluorescence and color image. And there is a figure of the machine. So you can see that the fruit will be transported in this conveyor, and it will stop in front of the camera. So the fluorescence and color image will be captured. And around them is the UV LED and white LED to catch the fluorescence and color image. So after the sorting, we can find that there are 20% of the sorted out fruits that actually looks normal to the eyes. So it might have some reasons why the fruits will fluoresce. So and there is an example of the image captured from the equipment. So you can see that the left one is the color image, and that looks normal. But when it transfers to the fluorescence image, it will fluoresce in the defective area. So we want to further to find out what is the possible reason of this. So we randomly select some samples to be tested further. And first, we use a UV image system to catch the fluorescence image. And this equipment includes a CCD camera and 4 fluorescence lamps with specific incident angle to have the uniform illumination, as a figure in here. But we can know that the fluorescence intensity is very low. So we need to adjust camera parameters to get a good quality image, and such as the shutter speed, gain, and gamma correction as in the table. And next, we use another equipment, and that is the digital microscope. And the purpose we use this equipment is because we want to get enlarged image for closer examination. So it includes a camera unit, zoom lens, and white LED, and 2 additional fluorescent lamps. And we also need to calibrate the camera parameters. So with the microscope, we can have the closer image and to get a good identification. So there is an example of the image we captured. Figure A. This is the fluorescence image captured by the UV illumination. And figure B and C is the color and fluorescent image captured by the microscope. And you can clearly see the defect from the microscope image. And figure D is the processed image. So it can have some defect information from this one here. And next is the result discussion. after we capture the image, we can find the defect classified to 4 classes. And first one is the physical damage, and rubbing against decayed fruit, green spot, and ring puffing. And as you can see from the figure, they are almost half of the portion is a green spot, and the rest are very close to each other. So the first one, the physical damage, thin scar. This kind of defect is due to the rough handling by knife or cutter during the packing, and it occurs mainly on the side or top portion near the calyx. As you can see from the figure, this kind of defect is very small and tiny, and it's difficult to see from the human eyes. So with the image, we can actually find out. And next one is the hole and flow. This one is due to the wind cause the fruit to rub against other things, or through the brushing procedures at the beginning of the sorting process. And this kind of defect, it will fluoresce. The fluorescence will be strong near the hole, and it will gradually decrease as the pure oil spread out further from the hole. So the fluorescence image will look like this one. And its size is also very tiny and small, about 3 mm in diameters. And the third one is a shrunk at calyx, and it is possibly caused by excessive gravity force or human force during the harvest. And it will look very normal. As you can see from the figure B, it looks very normal and no any defect. But under the UV light, you can see it actually will fluoresce. So it must have some reasons for defect inside the fruit. And next one is the rubbing against decayed fruit. And it is the fruit be affected by the rotten ones. So the rotten ones will have pure oil or spores, and it will be spread out to the fruit ones and affect them. So it will have the same fluorescence appearance as the rotten one have. And as you can see, the top one is affected by the pure oil, and the bottom one is affected by the spores. And the third case is the green spot, and there are almost half of the sample in this type. And in the color image, the appearance will be the yellowish green spot, little spot on the surface of the citrus, and the appearance of the fluorescence will look scattered, and the intensity will be very low. So, and the last one is the ring puffing. Ring puffing is a kind of the separation between the peel and the pulp. So the puffy area will be very sensitive to the damage, and the injured area will show a little depression, and it will actually fluoresce under UV light. So after identifying the physical reasons of the fluorescence, we want to see how this defective fruit will develop as time goes by. So we store the samples for 15 days, and we observe the deterioration patterns. And this is the result of the store effect. As you can see, thin scar and hole and flow, it will deteriorate quickly, and it will be rotten about 4 to 7 days. And the shrunken calyx will take a bit more time by day 10. And the rubbing against decayed fruit, the affected area will become weakened and become visible, and it will be rotten about a week. And the case in ring puffing, the oil cell will become depressed, and the oil cell in depressed area will become dehydrated and flattened, and the color in the surface will turn to the brown, as you can see from the figure E. The oil cell in the defective area will turn to the brown color. And in the last one case, green spot, it actually won't be rotten, but the green spot will become soft and apparent as time goes by. So, my conclusion is by using the UV illumination and microscope, we can actually identify the physical reason of the fluorescence. And with the categorization of the fluorescence, we can make the grading more efficient, and also we can find what is the reason fruit will be downgraded, and we can enable growers to minimize the loss. So based on this experiment, I think further experiment will be needed for other species of citrus, and we can go into further to find some other possible remedies. Thank you for listening, and welcome any questions.
Are there any questions?
Thanks for your presentation. And about your introduction, you mentioned that the cause of by the fluorescence is pure oil. And can you mean you can find the difference from the defect parts and the normal because of the oil?
You mean why I can identify the special defect or normal defect, or you mean I can identify which one is the defective fruit?
I mean, what's the part of the fruit can make the fluorescence respond?
And there is a special substance, but I actually forget. But the principle is because the defective area, such as the hole or the scar, and it will collapse the oil cell. So the pure oil will spread from there, and it have some special substance in the oil. It will fluoresce under UV light. So we use this principle to identify the defect. Does that answer your question?
Okay, and I have more questions about the system of this paper. And this one. And there have UV LED light and the white LED device. And what's the function of the white LED device?
Actually, it both takes the color and fluorescent image. All color and so color image. When we want to catch a color image, we use the white LED. So it will be catched 2 times. Yeah.
And do you know what's the wavelength of the UV LED device wavelength?
I need to find out. It's around 315 to 320 nanometers. Yes.
And the last question. And about the material and the methods, you mentioned that the image the image process is the gamma correction. And what is the gamma correction?
What is the gamma correction? This one. It will adjust the contrast of the image. So the low intensity intensity in the image will be transferred to the higher. So the contrast will be more obvious. I think that might be correct. Yeah.
Okay, thank you.
Thank you for your presentation. I want to know, the fruit is round in shape. So when the fruit goes through the transfer tape, do you need to rotate it to check the image from different sides?
Oh, okay. So you mean in part of this machine or this one? The first one. Okay. And as you can see the special design of the conveyor. This is actually not a flat surface, and it has the, how to say that, round surface, and it will roll the fruit. So you have the difficult and a different angle. Yes.
So, any questions from Japan?
Are there any questions?
Thank you for your presentation. I have two questions. Why is that UV sensor is not used very much at the sorting fruit place? And is this because the study has not yet advanced? And second one is there a place UV sensor is used? Thank you.
So can you repeat your question again?
First is the reason of the why UV sensor is not used very much at the sorting fruit place. And second is there the place anywhere the place using this UV sensor?
The sorting, the purpose of this experiment is not to sort the fruit. So we only want, the purpose is we want to identify the possible reason of the fluorescence. So the first machine I used, this is actually developed equipment. It is already used in the grading facilities, but it will identify the fluorescence, but we don't know why they fluoresce. So we want to know what is the possible reason. It only sort out the fruits that will have fluorescence, but we don't know why. So we know the reasons, we can have the matching remedies to minimize the loss when we grow the fruits. And does that answer your question?
Yes, thank you.
Thank you for your presentation. I have one question. You said microscope is used for the surface to check, but I think using microscope it takes much time to check. How much time to check the surface?
How much time? Sorry, it actually didn't mention in the paper, so and I have little experience using the microscope, so I can't answer your question. So
Thank you for your presentation. You show us a lot of reasons why there is fluorescence on the surface. But you are also able to discriminate using machine vision is reason of we can separate fluid, for example, with reflecting from fluid with fluid surface.
You mean how I can identify the different effects? Is that your question?
Is this system able to separate green citrus from reflecting citrus? Is it process or only to is it able only to show us process?
I think it didn't mention, but in my opinion, they can identify different effects such as ring passing or physical damage based on the fluorescent patterns, such as you can see the take the hole for example. If the effect is the hole, and it will have a strong intensity near the hole, but it will spread out. So the intensity will gradually decrease. So we can see from the fluorescent image with a strong intensity and low intensity around it. So we can see and we can identify at least effect is a kind of hole. So and as you can see from the ring puffing with the color image and the fluorescence image, it would be a wide range of the fluorescence. So I think it is the way it used to identify the different effects. Yes.
Thank you very much.
Thank you very much for your very detailed discussion for our own paper. Actually, there are many questions and answers between you, but some of them are something wrong discussion. Just one, I'd like to correct one thing. UV inspection systems are already actually developed and commercialized. So the farmers, most of the farmers need, and that's essential to introduce such a system to detect that, any small defects. So we need that UV inspection system. So far, that is already developed 3 years ago, 4 years ago, and recently they need that. Okay? Now distributing very much. Maybe 60%, 70% already introduced any R&D foods grading machine, but not all and pears yet. So probably some of them, some other new fluorescence imaging systems use other food grading systems. And another question is just enhance the low level pixels will be enhanced. That is a gamma question. And we use the UV lamp just 365 nanometer and 375 nanometer because that is just excitation wavelength and anything else. And there are many things you discuss. Thank you very much. That is a very good discussion. Good presentation. But just one thing, your presentation is too long. Maybe 7 minutes and minutes. So your presentation page is 24. Maybe I need to maybe next time you may put the presentation in time.
Thank you for your comments.
Maybe that's all from Japan. Thank you very much.